Okay, so what we're doing now is we're going to try to take these blow counts from the GEI report and turn them into engineering properties. And so really, if you kind of scroll down through our presentation here, this is our standard penetration test, and there's some details about the boring logs and so forth. But what we're really trying to do is we're going to take the blow counts from this test. So these are the blow counts, and that's the number of blows per 1 foot. And then we're going to apply these corrections. So we have the energy correction, the borehole diameter correction, the sampler correction, and the rod length correction. And then we're going to divide it by 0.6 because the correlations that were done for hammers that had 60% of the energy of modern hammers. And so what we need are some data. We need some blow count data. And so you can go to Blackboard and you download this Brookhaven demo. You open this up, and this has all of this data. So if you go over to lithology, there's the lithology, there's for borehole 104, there's 101, and so on and so forth. And so what we're looking for is we are looking for this data here. And we can export all this stuff. So the nice thing about GINT is it's sort of this walking database of all your different geotechnical data. So this is for boring 101, and here's boring 102, and so on and so forth. And so what you can do is you can go to File, Export, and then you can export it to an Excel file. So we're going to choose the type of file that we want to export it to. And then you can select individuals. In this case, we're going to select all tables. I'm going to click OK. And it tells you that it's what it's done. And so there should be 4-point records, and then we've got our sample records, and that's what we're interested in. So I'm going to click OK, and then I'm going to go off to Excel. And then I can go File, Open. And open them up. Okay, so here's the project data, and then we've got point data. Then we've got lithology for these different borings. And you can see that for each one of these, they're either going to be silty fill, or they will be well-graded sand. We've got sample data. And so this is the area that we're going to do all the analysis on. And so we're interested in these middle two borings. The first is going to have some slough, and so we're going to discard that, and the last might have some compaction, so we're going to discard that, and we're going to just use the sum of those two. So we're going to say that the N value is the sum of these two guys over here. And then we can copy those down. Now, what we're going to do is we're going to do some corrections. So if we go back, And so we have those blow counts. So that's the N value that we saw over here. And now we're going to do these corrections for energy and borehole size and all those sorts of things. And so the energy value, if you look at the boring log, it'll tell you that it's a standard or it's a safety hammer. So we come over to different types of hammers over here. Okay, and so for our borehole, it's a safety hammer. So we're going to use a correction factor between 0.55 and 0.60. So here we've got the energy, and I'm just going to say it's 0.575. Okay. And it went ahead and formatted that for me, so I would right click. Give it a couple decimal points. Okay. And then we've got a correction for the borehole. And so what we can do is we can open up the log for this boring, and when we do that, it shows that the size of the borehole was 3.75 inches. So here our correction factor is just 1. Now for the sampler, we're going to assume it's a standard sampler, so our correction factor for the sampler is just 1. We come over here to the rod, and so our rod correction is going to be based on the depth. And so depending on what the depth is, we'll have different correction factors. And so we've got for 10 to 13, so 10 to 13, we've got a correction factor of 0.75, and then for 13 to 20, we've got a correction factor of 0.85, and this formatting is annoying, but it is seeming to follow me around here. Oops. No. And then for 20 to 30, we've got 0.95, and then greater than 30, got a correction factor of 1. So for this example, I'm just going to say values that are less than 10 feet are also going to have a correction factor of 0.75, and then I can use a lookup table in order to determine what these values are. And so what this does is it takes that lower bound. So I'm going to call this my depths, and these are going to be my rod corrections. And then I can calculate my rod factors based on that. So I can look this up. I'll look up my value for my depth, and then it's looking for that vector of different depths, which is just going to be these values over here, and then the values that it's going to produce are these values over here. Okay. And then I can just double click, and it's selected my rod correction vector depths, and we can go over here and just double check and make sure that that did that. Okay, here we have 0.85. So for a depth of 15, so for going from 13 to 20, we should have had a rod correction of 0.85. So that did that all correctly. And then I'm going to give these names as well. This is your energy correction. And this is the borehole correction. And this is our sampler correction. So then we can develop our N60, and that's just going to be equal to those blow counts multiplied by your efficiency, multiplied by your borehole, or multiplied by your sampler, multiplied by your rod correction divided by 0.6. Okay, and I've made one small mistake, and that is that this factor up here, this EM, should have been my energy correction. I'll just give it a number 2 just in case I have named it someplace like that. Portion, and then it should fix that. Okay, so now what I've done is I've calculated my N60 values. And at this point I'm just going to take a little break, and then we'll come back and calculate the stresses and calculate our N160 values.